This video is for those of you who want to understand functions. So in this tutorial, we are going to talk about relations and functions, basics of the functions, inverse functions, composite functions, quadratic functions, domain and range of the function, piecewise functions, odd and even functions, polynomials, rational functions, modulus functions, and radical functions. So let's begin our discussion with relation and functions. What is a relation? Basically, when we're talking about relation, we're talking about a set of pairs of input and output values. Now, when we're talking about the input values, what are we talking about? The input values, these are the x values. Okay, at the same time, this is the domain. So we are saying that this is the pair of the input and output values. So when you talk of the output values, these are y values. Okay, then at the same time, this is a range. So whenever you hear to say domain, we're talking about the x values. The range, we're talking about the y values. Let's say we have got a function, to say a set of function 1, 4. Then we have 3, 4. Let's also have 7, 3. Okay, so as you can see, the first part here is our x value. This is y, this is x, this is y, this is x, this is y. Now they can ask you to list the domain. The domain in this case is going to be, so we start from ascending, so it's going to be 1, comma, we're going to have 3 and 7. So this is our domain. Okay, what of the range? So the range of the values in this case, we're going to have 3. We start from 3, then we're going to have 4. We only have 2, so this is our range. Okay, now how can we map this? We can see that the x values, the ones we are calling them as a domain, we're going to put them here. We're going to say that this is x and then this is y. So to map them, we're going to say that we're going to have something like this, then we're going to have something like this. So we put the values here. We can see that we're going to have the x values, we have got 1, 3 and 7. The y values, we have got 3 and 4. Now let's see. 1 is mapping to what? 4. So we're going to have 1 all the way to 4. So it's going to come from here all the way to 4. Next we have 3 to 4. 3 to 4. Okay. Next we have what? We have 7 to 3. 7 to 3. Now, is this a function or not a function? So this is a function because all the values of x, they are mapping to the values of y. Okay? So now, in short, for us to consider a function or a relation to be a function, all the input values must have an output value. Then we are going to call that one as a function. Not only that, but we should also note to say there should be only one output for each input. Okay? So for each input here, I need to have only one output. Perhaps you have seen some equations which maybe we have got this. Okay, is equal to 0. It's possible we can find two values of x. Perhaps we have seen maybe x is equal to plus or minus maybe 2, meaning we've got x is equal to 2, x is equal to negative 2. Okay, you can have two values of x mapping to one value of y, but it is not possible of you having two values of y mapping to one value of x. So once you see to say one value of x is mapping to two values of y, that is going to be wrong. That is not a function. Okay, for example, let's say we have a function. Let's have this. Let's have this. Let's see if this is going to be a function. Let's say we have 1, 2. Then let's have 1, 3. Let's have 2, 3. Let's see if this is a function. We are saying that for us to consider something to be a function, all the input values must have an output value, meaning that all the element of x, they are supposed to have the output value. At the same time, there should be only one output value for each input. Okay, so we have got 1, we also have 2. Then the output values, we have 2 and 3. Let's see. So 1 is mapping into 2. At the same time, 1 is also mapping into 3. Then 2 is mapping to 3. Now we are saying that we can have two values of x mapping to two different values of y. Okay, we are saying that we can have two values of x mapping to one value of y. That is just okay. Okay, but it is not possible of having two values of y mapping to one value of what, of x. Okay, so as we can see here, we cannot call this one to be a function because one is having two output. It's not possible that we have the input value. It's not possible that the input value can have two output values. So we are going to say that this is not a function. Okay, so now from there, let's also talk about one-to-one function. So let's say we have got a function. Let's have this. Let's also have this. Let's say we have 1, 2, 3, 4. Let's have 3, 4, 5, 6. So let's say 1 is mapping to 3, 2 is mapping to, this is mapping there, this is mapping there. So we have got x and y. Now what you need to understand here is very simple and straightforward. So this is going to be a function because each input value has got an output value. At the same time, each output value is only mapping to one values of y. Then we can say that this is one-to-one. This is one-to-one function because only one element of y is going to one element of x is going to one element of y. 1 is going to 3, 2 is going to 4, 3 is going to 5, 4 is going to 6. So this is one-to-one function. Let's have another one. Let's say we have a different one. Okay, let's say we have 0, then we have 1, we have 2, then let's have also -2, although I was supposed to start from here. This is going to be -2, 0, 1. Then we're going to have what? We're going to have 2, just like this. Then let's have 0 here, let's have 1, let's have 4. Now let's say that this is mapping there, then at the same time 0 is mapping to 0, 1 is mapping to 1, this is mapping to. So this, perhaps this is a function. Okay, let me redo it. We say this is mapping to 1, but 0 is mapping to 0. Okay, it is possible that two values of x can give us one value of y. That is just okay, but it is not possible that one value or two values of y giving us one value of x. It's not possible. So here we can see that this is going to be a function, but this function, what type of the function is this? This is many to one. Okay, many to one. Why are we saying many to one? Many values of x are going to one value of y. As we can see, -2 and 0, they are going to 0, only 0, meaning that it is many to one. So two values of x, they are going to one value of y. That is, it is a function. And what type of the function? It is many to one. Okay, then there's also what we call, let's have this, a different one. We see what we're going to have. Let's say we have 1 here, let's have 9, and let's have a 0. Okay, then this side, let's have also a different one. So we're going to have 1 here, we're going to have 3, this is going to be -3, 0. So let's say that 1 is going to 1, then 9 is going to 3, at the same time 9 is going to -3, then 0 is going to 0. Remember, we said that we cannot have two values of x of y going to one value of x. So this is not a function. 1 is not a function. 2, this function, as we can see, it is one to many. It is not a function, but it is a one-to-many function. Okay, why are we saying it is one-to-many? We can see that one element of x is going to two values of what? Two values of y. So it is one-to-many, but it's not a function because we have got one element of x which is mapping to two different element of y, which is not possible. Okay, it's possible we can have two element of x going to one member of y. That is just okay, but not one member of x going to two members of what? Of y. That is not going to be a function. Okay, so now let's say we have a different one like this. So we have one, let's have two, let's have three. Next, let's have this. So let's say that this is a, this is b. So we have 4, 5, and then 6. Let's say that one is going to, this is going there, then this is going there. At the same time, 3 is going there. At the same time, 3 is also going there. So as we can see, one element of x is going to two elements of y, or one element of a is going to two elements of what? B. At the same time, two elements of a, they are going to one element of what? B. So this is not a function. It is not a function because one element, okay, two elements are going to one element of a is giving us two different elements of what? Y, which is not possible. Okay, so now we can say that this is many to many. This is many to many, but it's not a function. Okay, now let's say you have this. So let's say this is x and then this is y. Let's have a, b, c. And then here we have capital A, B, C. Now let's say this is going here. Okay, then this is going there, it's also going there. So we can see that this is not a function. One is not a function because two elements of y, they're giving us one element of x, one, and at the same time all the elements of x, they're supposed to have an output. So this is supposed to be mapped. So if you have got any element which is not mapped to anything, as long as that element is in x, then that is not a function. Okay, what if I change this, then I put it like this? Okay, I put it like this, or we say this goes here, then again this one goes there. So this is going to be a function. It is possible we can have all the element of x, which we can see that the input has got an output value, but still we have got one member which is not mapped. As long as that member is in y, then that is just okay. But we are supposed to have all the element in x, they're supposed to be mapped. So all the element of the input values, they're supposed to have what? The output. But it is possible that the output cannot have the what? The input. That is just okay. So we can consider that one to be a function. Okay. So now let's see how we can solve this. We have got this question which is saying find the domain and range of each of the following function. So let's start with the function or the domain. So the domain in this case, we know that these are the x, so we're going to start with getting from the ascending order. We're going to have 0. So we start from 0. From 0 we have 3. 3 we have 5. 5 we have got 8. 8 then we have got 9. So this is our domain. Okay, what is the range or the function f? The range is 1. 1, then we are going to have 4. 4 we're going to have 7. 7 we're going to have 11. 11 we're going to have 12. That is our range. Okay, so go ahead and find the domain and range for the function g. You can pause the video and find the domain and range. Okay, so there we go. So the domain in this case is going to be, we're going to start with negative. We're going to start with the one which is the lowest, which is 10. We've got 10, 20, 30, 40, and 50. That is our domain. Okay, so what is our range in this case? The range, these are the values of y. So you can see that we have got this, this here, we have this, we have also this. So that is our range. So we can list the range here. We can see that our range is going to be negative 4 comma 6, or is comma 1. We have got 1 comma 1 comma 6 comma 9, then we have got comma 13. So this is our range. Okay, so that is it for question 1. Now the next question is saying, which of the following set of ordered pairs represent a function? So let's see, we have got the first one. So the first one, we can see that we're going to have, so allow me to put x and y. So I'm going to do this. Okay, that is what we're going to have. Also have this. So what is our x? Our x, we have got 1, that is the domain. I'm getting the first part here. So I'm having this one, this one, this one. Okay, so I'm having 1 3. Okay, I'm having 1 3 and what, and 7. The y values, we have got a 4, and so you start with 3. We have got a 3 and a 4. So let's see. 1 is mapped into what? 4. So 1 goes to 4, 1 going to 4. We put even arrows. Then 3 is going to 4, 3 is going to 4. Okay, 7 is going to 3, 7 is going to 3. So is this a function? Yes, it is a function. 1, because all the input values have got what? The output values. Next, we can see that only one input value is having what? Only, we need to have only one input value. For every input value, we need to have the output values. Okay, that is the first point. Then the next point, we can see that it is okay, we can have two different elements of x, they can go to one to the same element of y, but it is not possible as having two different elements of y going to one element of x. Okay, so this is a function. Okay, so let's go to part B. We go to part B, we see if that is a function. So we're going to have also x, y. We have this, we have this. What values do we have? We have got 1, we have got 2, that's all. Then we have got 3, and then we have got what? We have got 2 and 3 here. 2 and 3. So we can see that 1 is mapped into 2, then 1 is mapped again into 3, 2 is mapped into 3. So one value of x is going to two different values of y, which is not correct. So this is not a function. So only one value of x is supposed to be going to one value of what? Of y. Or two elements of x can go to one element of what? Y. That is just okay. And not one element of x mapping to two different elements of y, meaning that is not a function. Okay, so let's see, we have question 3 here, which is saying let set a to be equal to, so we're going to be using that. We have been given a and b to be equal to, okay, we have got 0 1 2 and 3. Then the b is negative 2 negative 1 0 1 2. Now the first point here, they are saying which of the following set of ordered pairs represent a function from a to b. So the first point, which is part a is 1 comma 0. So 1 comma 0 is going to be, we start from 1 all the way to comma 0. So where is 1? We have got 0 comma 1. So 0 here all the way to 1. Next is 1 and negative 2. So 1 here all the way to negative 2. Next is 2 comma 0, 2 comma 0. Okay, let me redo that one. 2 comma 0 is here. Next is 3 comma 2, 3 all the way to 2. So is this a function? We can only consider to say it's a function as long as all the values of x, all the values of a, they appear, they have got an output value. Okay, so as we can see, even if this one is not mapped to anything, but as long as all the values of x, they have got the output values, then that one is going to be a function. Then one value of x cannot go to two different values of what? Two different values of y. So as we can see here, all the values here, each value has got just one output here. So we are going to consider this one to be a function. So part one, this is, we are going to say this is a function. Okay, so let's go to part B. I'm going to use the same one. Part B is saying we have 0 comma negative 1, 0 comma negative 1, then 2 comma 2, 2 comma 2. Next we have 1 comma negative 1 comma negative 2, 1 comma negative 2, that one. We have 3 comma 0, 3 comma 0, 3 here comma 0. Next we have 1 comma 1, so 1 here comma 1. So this element, which is for a, this element is giving us two different values of y, meaning that this is not a function. So this is not a function because one element of a is giving us two values. So one input is giving us two output, which is not possible. So we said that there should be only one output for each input. As simple as that. So this is not a function. Let's go to the next one. We go to part C. Is part C a function? Let's see. We have got 0 comma 0, 0 comma 0 is this point here. Then you have got 1 comma 0, 1 comma 0 is going there. Then 2 comma 0, 2 going there to 0. That is just okay. Then 3 comma 0 again, this one going there. That is just okay. So is this a function? So this is a function, yes, because all the output values or all the input values, they have got what output value. So we said that there should be only one output for each input. So we can see here that this input here has got the output, this one has got output, this one has got output. So this is what this is. We're going to call this one as a function. Okay, perhaps you have seen equation which is starting x to the power 4. You can have 4 different values of x giving us one value of y. So this is a function. Let's go to part D. So part D is 0 comma 0 comma 2, 0 comma 2, which is there. Oh, it's 0 comma 2, not negative. 0 all the way to 2. 1 comma what? We have next is 3 comma 0, 3 comma 0. So my 3 is here comma 0. Next I have 1 comma 1 comma 1, 1 comma 1. That is just okay. But all the outputs all the input values, they're supposed to have the output value. So as we can see, this input here has got nothing. It's not mapped to anything. So this is not a function. Okay, so this is what we need to know under relations and functions. So let's talk about one-to-one function. So how do you know that a function is one-to-one or is main to one? Okay, so a function is said to be one-to-one if f of a is equal to f of b. Okay, so if f of a is equal to f of b, then we're going to conclude to say this function is one-to-one. So for example, let's have one question here. Let's say we have a function which is f of x is equal to x squared minus 1. So let's see, is this function one-to-one? Let's prove. Okay, so a function is said to be one-to-one if f of a is equal to f of b. So what it means here is that in this function, where there is x, I'm going to put a. So I'm going to say it's going to be a squared minus 1 has to be equal to b squared minus 1. So I can shift 1 to the other side. It's going to be plus, which is going to be a squared has to be equal to b squared minus 1 plus 1. So these two can cancel out. It's going to be 0. So we're going to have a squared is equal to b squared. So we are trying to make a as a subject of formula. What are we going to do? It's going to be, we are going to square both sides. Now, the moment when I square this side, meaning that I'm going to have uh, this side is going to be plus or minus. So it's going to be a is equal to plus or minus b. So this mean what it means here is that a is equal to b and a is equal to negative b, which is not true. So we are saying that a function can only be said to be one-to-one if a is equal to b, okay, and not a is equal to negative b. So as we can see here, we have got two values. We have got a is equal to b and a is equal to negative b, meaning that this function is not one-to-one. Okay, so this function is not one-to-one because a is not equal to b. So you say after reaching at this stage, you know that a is equal to plus or minus b. Then you're going to say that this function is not one-to-one since f of a is not equal to f of b. As simple as that. Okay, so let's have another example. Let's say we have a function which is f of x is equal to x plus 5. Let's prove, let's see if this function is one-to-one. So a function is said to be one-to-one if f of a is equal to f of b. Okay, so what it means that in the first part where there is x, I'm going to put a, so it's going to be a plus 5 has to be equal to b plus 5. I can shift 5 to the other side. It's going to be a is equal to b plus 5 minus 5. So these two guys are going to give us 0. So we're going to have a is equal to b. So as we can see, a is equal to b, meaning that this function is one-to-one. Okay, so this is how you prove that the function is one-to-one. Okay, so let's have one more example. Let's say we have f of x to be equal to the square root of x. Let's prove that. Let's see if this function is one-to-one. So a function is said to be one-to-one if f of a is equal to f of b. So let's see. So we're going to say the square root of a has to be equal to the square root of b. Okay, so I can square both sides to remove the square root. So if I do this, I'm going to find that a will be equal to b. So this function is one-to-one. Okay, so another example which we're going to have is very simple. Let's say we have f of x is equal to 2x minus 3. Let's see if this function is one-to-one. So a function is said to be one-to-one if f of a is equal to f of b. So as we can see, this is going to be 2a has 2a minus 3 has to be equal to 2b minus 3. So what I'm going to do, I'm going to shift this to the right hand side. Then I'm going to have 2a is going to be equal to 2b minus 3 plus 3. So these two are going to give me 0. Okay, therefore I'm going to have 2a is equal to 2b. So I can divide both sides by 2. I can see that a is going to be equal to b. So therefore this function is one-to-one since a is equal to b. Okay, let's have one more example. Let's say we have f of x is equal to x squared. So I believe this is going to be the same as the first example, where we're going to say a squared is equal to b squared. We get the square root both sides. We're going to have a is equal to plus or minus b. So since f of a is not equal to f of b, this function is not one-to-one. Okay, sometimes you might think of the relations. So let's say we have x and then you have y. So let's have this now. We see how can you represent a one-to-one function using mapping. So let's say this is a, this is b, this is c. Okay, then this is maybe capital A, capital B, capital C. So if this one goes there, this one goes here, okay, once again this one goes there, then this one goes here. So as you can see, every element of x is only mapping to one element of y, meaning that this function is one to one. Okay, as simple as that. So using mapping, this is how you can tell to say this function is one to one if every element of x is just mapping to one element of y, meaning that is one to one. Okay, so there's also what we call many to one. So there's also what we call many to one. So many to one is whereby you have got a function. Let's say this is our mapping. Okay, want to see the relationship which is going to be there. So let's say this is A. Okay, this is A, this is B, this is C, and then let's have Z here. So if this one is mapping here, this is what's going to happen. So this is what we call many to one. So what is happening here is that many values of x, they are only relating to one value of y. So that's why we're calling it as many to one. So this is many to one function. Okay. Now, sometimes it's possible you can use the graph to say this function is one to one. Okay. So if I have my graph here, okay, then I have got a curve which is like this. Let's say maybe it's coming from here. Okay. So if you draw a line, if this line cuts only one side of the is only cut one side of the graph, meaning this function is one to one. So for example, here it's just cutting here, meaning this function is going to be one to one. So for example, maybe if you have been given something like this, let's say you have got your graph and then you have got an equation which is like this. Okay, so if I cut my graph here straight, I'm going to draw a straight line, maybe from here all the way to this side. As you can see, it is touching three sides. Okay, meaning that this is many to one function. So this is not one to one function. A one to one function is only supposed to touch one side of the graph. So if maybe you also have something like this, this is also not meant to one, because sometimes you can have this is f of x is equal to maybe x squared. Okay, we even proved that this is not one to one. So as you can see, it's going to touch two sides. It's going to touch here and here. So this is not a one to one function. So this is how you know that a function is one to one or is not one to one. Then many to one is when you have got more values of x, then they are mapping to one value of y. That is many to one function. Okay. Okay. So if you've been given a function, then they ask you to say find f of 4, find f of negative 4, find f of 2. What it means there is that where there is x, this is the first equation. Where there is x, we need to put 4. Then we need to find the value. Okay, meaning that what it means there is f of 4 is going to be equal to, in this function where there is x, I need to replace it with what? 4. Okay, so as we can see there, it's going to be 4, but x is squared, so it's going to be 4 squared. Okay, minus 6. Okay, then this is going to give us f of 4 is going to be 4 squared is 16. 16 minus 6 is going to give us a 10, meaning this is the answer. Okay, so we go to part 2, which is saying f of negative 4. So f of negative 4 is going to be negative 4 squared minus 6. So negative 4 squared is going to give us 16. Then 16 minus 6 is going to be 10. So part 1 and part 2, the answer is going to be the same. Okay, let's go to part 3. Part 3 is saying if we have been given this function, then they ask us to find f of 2. how can we find this? So this is going to be 2 squared minus 6. So 2 squared is going to be a 4, minus 6 is going to give us negative 2. So the answer for part 3 is negative 2. Okay, sometimes they can ask us to say this function which have been given, okay, we have been given the function to say f of x to be equal to x squared minus 6. Then they ask us to say, given that f of a is equal to a, find the possible values of a. So what it means there is that in the first part, where there is a, where there is x in the first equation, we have to replace it with a. Okay, then you have to equate it to what? To a. Then we need to find the values of a. So what it means there is that we're going to have f of a is going to be equal to a squared minus 6. Now they want us to put where there is this with a. Then this is going to be a is going to be equal to a squared minus 6. So they want us to find the possible values of a. So we have our equation now, which is a has to be equal to a squared minus 6. What should we do? I can just shift 6 to go to the left hand side, then a to go to the right hand side. So it's going to be 6. It's going to be equal to a squared minus a. Okay, I can factor out in a now, which is the same as, I can just write this, it's the same as a squared minus a has to be equal to 6. I can now factor out a. So a will be open brackets, then we're going to have a minus 1 is equal to 7. Okay, now from here we can see that a is going to be equal to 6 and a minus 1 will be equal to 6. Therefore a will be equal to 6 plus 1, meaning that another value of a is going to be 7. So the possible values of a in this case is going to be a is equal to 6 and a is equal to 7. As simple as that. Okay, let's have another function. Okay, let's have different one. Let's say we have been given f of t to be equal to the square root of 25 minus t squared. Now they ask us to find f of 3. Then they ask us to find again f of x plus 5. Again they ask us to find f of 2x. What can we do? So without wasting our time, what we're going to do here is what it means here, the first part, the first question, where there is t, we are going to replace it with 3. Then we need to find the value. Okay, so there we go. It's going to be f of 3 is going to be equal to f of 3 is going to be equal to the square root of 25 minus, where there is t, let's put 3, minus 3 squared. So f of 3 is going to be 25 minus 9. Okay, so my f of 3 is going to be 25 minus 9 is going to be a 16. Okay, 25 minus 9 is going to give us a 16. Now the square root of 16, we're going to have a 16, and the square root of 16 is 4. So the answer for part 1 is going to give us a 4. Okay, let's go to part 2, where they want us to find f over x plus 5. So what will be f of x plus 5? This is going to be equal to, where there is t, we are going to put x plus 5. Okay, so it's going to be the square root of 25 minus, open brackets, x plus 5, but t is squared, so I have to square this. So my f of x plus 5 is going to be equal to, this is the same as 25, then it's the same as, I can say x plus 5, x plus 5, and I can expand this. It's going to give me what? It's going to give me x times x is going to give me x squared, x times 5 is going to give me 5x, then again 5 times x is going to give me 5x, 5 times 5 is going to give me 25. meaning that this is the part which I'm going to put it there, but this is the same as x squared plus 10x plus 25. Okay, because 5 plus 5 is going to give me 10. So I'm going to have minus. Now this negative is going to affect everything inside there. So we're going to have x squared plus 10x then plus 25. Now we can get rid of this. So now from here we can see that our x plus 5 is going to be the square root over, we are going to have 25. This is 25 minus, I'm distributing now, negative is going to be minus x squared minus 10x minus a 25. Okay, now at 25 and 25 is going to be 25 minus 25, so they are going to cancel out. It's going to be 0. Okay, then we are going to have f of x plus 5 is going to be, we're going to have negative x squared minus 10x. Okay, so this is the final answer for part 2. Okay, now we can also find part 3. You can pause the video and find the answer, then you continue with it. So now there we go, we have f of 2x. This is going to be where they still need to put 2x, so we're going to have a 25 minus, so this is going to be 2x, but it has to be squared. Okay, so my f of 2x will be equal to, I'm going to have a 25 minus, this is going to be 4x squared. Okay, and there is nothing that I can do with this equation now, with this function, so I'm going to end there. So I'll say this is my final answer. Okay, so that's what you need to know. Now let's talk about the inverse of the function. So how do we find the inverse of the function? So let's say we have been given a function f of x to be equal to 2 then divided by x minus 2. Okay, and then let's also have a g of x to be equal to let's just put it as 1 divided by x plus 1. Now what if they ask us to find f of inverse? So inverse, sometimes they can ask you to say find 1 over f of x. So 1 over f of x, it is the same as f of inverse. Okay, it is the same. Okay, so sometimes they can use 1 over f of x, that is the same as the inverse. So now in this case we want to find f of inverse. Now how do we do it? To find the inverse of the function, what you have to do is you replace this part with y and then make x as a subject of formula. Okay, now after making x as a subject of formula, where there is y, replace it with x, then that is the inverse of that function. So for example, in this case we have f of x is equal to 2 over x minus 2. So where there is f of x, I'm going to replace it with what? With y. So I'm going to say that y will be equal to 2 divided by x minus 2. My goal here is to make x as a subject of formula. So I'm going to say I'll cross multiply. Here there is 1. So I'm going to say this is going to be xy minus 2x. This is going to be equal to 2. So my goal is to make x as a subject of formula. So I'm going to say that I'm going to shift 2y to the other side. Xy has to be equal to 2 plus 2y. Okay, from here what I'm going to do, I'm going to divide both sides by y, both sides by y. Therefore my x will be equal to 2 plus 2y divided by y. Now what I'm going to do now from here is, in this part here where there is y, I'm going to replace it with what? With x. So I'm going to say my f of inverse of x is going to be equal to 2 plus 2x. Where there is y, I'm replacing back with what? X. Everything divided by what? X. Okay, now if you want, you can factor out 2 on top there, but it's okay, you can just leave it here, meaning that this is the function of f of x. Now let's find the inverse. Now we are saying that our f of, this is our f of inverse, which is 2 plus 2x over x. Let's find the inverse of the function of g. So what would be the inverse in this case? Remember, we are replacing this with, we are trying to find this. So what I'm going to do, I'm going to replace this with y and make x as a subject of formula. I'm going to say that y will be equal to 1 divided by x plus 1. My goal is to make x as a subject of formula. I'm going to cross multiply. So I'm going to have xy plus y is going to be equal to 1. Okay? I'm going to shift y to the right hand side. It's going to be xy will be equal to 1 minus y. Next, I'm going to divide both sides by y. Both sides by y. My x will be equal to 1 minus y divided by y. Meaning that my f of, my g of inverse is going to be equal to, now where there is x in this part here, where there is y, I'm going to replace it with what? With x. So it's going to be 1 minus x divided by x. So this is my inverse of g. Okay, now from there they can also ask us to find, from there they can also ask us to find they can ask us to find f of g, then they say inverse. So what it means there is that they want us to find f of g first, then we need to find the inverse of that f of g. Okay, so this is what we are going to do. First I have to find f of g. Okay, so what will be my f of g? What it means here is that we did this is a composite function. So what it means here is that in the function of f, where there is x, I'm going to put g. Okay, so for example here is going to be my f is 2 over x minus 2, but where there is x I have 2 over x. Where there is x, I'm going to put 1 divided by what? X plus 1. Then I have minus 2. Now what I'm going to do here, I'll need first to finish up with this part, the down part here. So what will be the down part? This down part here, it is going to be 1 over x plus 1, then we have 2, then this is the same as we have 1 here. So I'm going to say my common denominator is going to be x plus 1. So x plus 1 there, we're going to have 1 here, minus this one, we're going to have a 2x minus 2. So on top there is going to be 2 and 1 is going to give us negative 1. So we're going to have negative 2x minus 1 over x plus 1. This is what we're going to have here, meaning we have this now. We have 2 divided by negative 2x minus 1 over x plus 1. So this, we have 2 on top divided by, we have a negative 2 minus 1, negative 2x minus 1, then everything divided by x plus 1. Now this again is the same as 2 times, I'm going to get the reciprocal of this, is going to be x plus 1, everything divided by negative 2x minus 1. Okay, so now I'm going to say 2 times x and 2 times 1, which is going to be 2x plus 2, everything divided by negative 2x minus 1. Meaning that the whole of this is now going to be replaced by 2x plus 1 divided by negative 2x minus 1. Okay, so I'll continue from here. Okay, I'll continue from here. I'm going to say that the whole part there is going to be replaced by, we are going to have a 2x plus 2, everything divided by negative 2x minus 1. Now this is f of g. Now they want us to get the inverse of this, but what I have to do here, I can factor out negative down there if I want, but if I want to leave it like this, I can leave it. So this is f of g. Okay, so this is our f of g, of x. Now they want us to find the inverse of this. So we're going to replace this part with y, then we make x as a subject of formula. So it's going to be y is going to be equal to 2x plus 2 divided by negative 2x minus 1. Okay. Now from here, I'm going to make x as a subject of formula. I'm going to cross multiply, and I'm going to have negative 2xy minus y, because 1 times y is going to give me y, so it's going to be is equal to 2x plus 2. I'll shift 2x to the left hand side. At the same time, I'm going to shift the y, negative y, to go to the other side. So what are we going to have? So this is what we're going to have. We are going to have negative 2xy minus 2x has to be equal to we have 2 minus, this is, it was minus, so this is going to be plus y. My goal is to make x as a subject of formula. That is going to be my inverse now. So I'm going to say I need to factor out x, so I'm going to have x open brackets. I'm going to remain with negative 2y minus 2 has to be equal to 2 minus y. I'll divide both sides by negative 2y minus 2, even here by negative 2y minus 2. So these, they'll cancel. I'll have my x to be equal to 2x, or is 2 minus 2 plus y divided by negative 2y minus 2. Now from here, this is my inverse. Where there is y, we're going to replace it with x, as we know. So this is going to be now equal to, where there is y, I'm going to replace it with what? So it's going to be plus x, everything divided by negative 2x minus 2. But if I want here, I can factor out negative. That is going to be very much simple for us. What I'm going to do is I'm going to say 2 plus x, everything divided, negative is going to be like this, plus 2. So now I can divide both sides by negative. It's going to be negative 2, which is the same as, I can start with x. It's going to be negative x minus 2, everything divided by 2x plus 2. So this is going to be my final answer. Okay, so let's talk about composite function. So under composite function, you're going to be given more than one function. For example, let's say we have our function f of x to be equal to 2x squared plus 2, and then we also have g of x is equal to x minus 1. Then they also give us to say h of x, which is going to be equal to 3x. Okay, now sometime they can ask us to say find f of g of x. What does it mean? Okay, so when we say f of g of x, what it means is that in the function of x, where there is x in the function of f, where there is x, we are going to put the whole function of g. So it is f of g. Okay, so in the function of f, where there is x, we are going to put the whole function of g. Okay, so in this case, the function of f is 2x, is this one. Okay, now in this function, where there is x, we are going to put what? We are going to put g, which is this one. Okay, so we're going to say f of g of x is going to be equal to, is going to be 2, then open brackets. Where there is x, we need to put x minus 1. So x minus 1 is the function of g. Okay, then since this x is squared, I have to square this, plus 2. Now I need to find the value here. Although it's not going to be a value, but I need just to simplify it. Okay, so I'm going to have x, this is the same as x minus 1, at the same time x minus 1. So x times x is going to be x squared, x times 1 is going to be negative x, Then we're going to have negative 1 times x going to have to be negative x. Then we're going to have 1 times negative 1 is going to be positive 1. So this is going to be x squared minus 2x plus 1. Okay, so we're going to have a 2 open brackets. We're going to have x squared minus 2x plus 1. Okay, this we have plus 2 here. Now we can simplify this. Is going to be 2 times x squared is going to be 2x squared minus, this is going to give us now a 4x plus a 2 and then plus 2. So our final answer is going to be 2x squared minus a 4x plus 4. So this is the final answer of f of g of x. Okay, now that is part 1. Now let's say maybe they ask us to say find g of h, then they put us x here. So what it means there is that in the function of g, where there is x, we need to put the function, we need to put what? H. Okay, so what it means is that the function of g is just x minus 1. So where there is x, we are going to put 3x, because 3x is the function of h. So it's going to be 3x minus 1. So there is, I can't simplify this, so it's going to end there. Okay, now what if I've been given h of f? Okay, I need to find this. What it means is that in the function of h, where there is x, we're going to put in f. Okay, so we are going to have 3. Where there is x now, we are going to put f. F is 2x squared plus 2. Okay, we can simplify this, or we can just expand. In short, it's going to be 6x squared plus 6. So we can end here. If you want, you can leave it there, or you can expand, leave it there. Okay, now let's have different thing. Let's have another question. Okay, let's say we have just 2 functions. Let's say we have f of x to be equal to 2 divided by x. Then you have g of x to be equal to x minus 3. Now let's say we want to find f of g of x. Now, like I said, where there is in the function of f, where there is x, we are going to put g, meaning it's going to be 2 divided by, where there is x, we are going to put x minus 3, meaning I can end there. So that is going to be my answer. Now what if they ask us to find g of f? That is going to be the opposite now. So what it means there is that in the function of g, where there is x, we put f. So x, we are going to replace it with that 2 over x. So it's going to be 2 over x minus 3. As simple as that. So if you want, you can end there, or you can say that is going to be the same as you have 2 over x minus 3. It's going to be the same as if you say x, then x there, we are going to have 2 minus 3x. So you can also end here, which is just the same as ending there. Okay, now let's have a different thing. Let's say we have again 2 functions. We're going to use f and g again. So let's say we have our f to be, let's say f of x is 2x plus 3. Then our g of x is 2 minus x squared. Okay, now if they ask us to find f over g then of 0, what it means that if we find f of g, where there is x, we're going to replace it with 0, and then we find the value. So what we're going to do here is first we have to find f of g. Okay, so if I'm to find f of g, what will be my f of g? My f of g of x before I plug in 0 is going to be in the function of f. Where there is x, I need to put g. So in this case, we are going to have, this is x, so it's going to be 2. Where there is x, I'm going to put 2 minus x squared plus 3. So this is going to be f4 minus 2x squared plus 3. I can simplify this and say this is going to be 4 plus 3 is going to be a 7 minus 2x squared. Now they are saying that where there is x now, we are going to replace it with 0. Okay, meaning that we are going to continue from here. We are going to say 7 minus 2. Where there is x, we put 0. 0, then we square it. So this is going to give us 0 squared is 0. 0 times 2 is going to be 0. 7 minus 0, we are going to get what? A 7. So our final answer in this case is going to be what? A 7. As simple as that. Okay. Now, what if they ask us to find g of f? Then we say 0. Okay. They ask us to find g of f. Then we find 0. So this is going to be, we find first g of f. So where in the function of g, where there is x, we are going to put f. G is 2 minus x squared. Now where there is x, I have to replace it with what? 2x plus 3. That is f now. So it's going to be 2, okay, minus, I'm going now to put this in brackets, 2x plus 3, then I have to square it. So this is going to be 2 minus, this is the same as 2 times 2 is going to, is 2x times 2x is going to be 4x squared. Then 2x times 3 is going to be plus 6x. Again, 3 times 2x is going to be plus 6x again. Then 3 times 3 is going to give us what? It's going to give us a 9. Okay, so this is going to be 2 minus, this is going to be a 4x squared plus a 12x plus 9. I can now distribute the negative, so it's going to be 2 minus 4x squared minus 12x minus 9. So 2 and 9 can go, so it's going to be 2 minus 9 is going to be negative 7. So I'm going to have negative 7 minus 4x squared minus 12x. Now they are saying that where there is x, we put 0. So this is going to be negative 7 minus 4 0 squared minus, then we're going to have 12, again 0. So this part is going to give us 0. This part is going to give us 0. So our final answer will end up having negative 7. So that is going to be our answer. Okay. Now we can have a different one where we say the same one. Let's try to find f of f, then we need to find 4. So what it means that f of f, in the function of f, where there's x, we put f again. So our f in this case is 2x. Now where there's x is 2x plus 3. So where there's x, we're going to put the same function again. So it's going to be 2 open brackets, then 2x plus 3, then again plus what? 3. Okay, so it's going to be 2. So we can say 2 times 2 is going to give us what? It's going to give us a 4x plus, this is going to be a 6, then plus 3. Okay, so now we can see that from here it's going to be a 4x plus 9. Where there is x, we put 4, so it's going to be 4 times 4 plus 9. 4 times 4 is 9. 4 times 4 is 16. Then 16 plus 9 is going to give us a 25. So 25 is the answer in this case. So let's talk about how to find the domain and the range of the function. So whenever we're talking about the range and the domain, so let's start with the domain. Whenever we're talking about the domain, these are the values of x. Okay, And whenever we're talking about the range, these are the values of y. So let's say we have the function f of x is equal to 2x plus 1. Now, whenever they ask you to say find the domain of the function, the values of x, which when we plug in here, the function is going to be defined. So in this function, I can plug in any value of x. This function still is going to be defined. Any value, meaning that the domain is all real numbers. Okay? But now let's say you have a function. Let's say you have a function which is f of x, and then you have maybe 1 divided by x plus 1. Then they ask you to find the domain. Now here you can't say it is all real numbers because we have the fraction. So on the denominator here, once we plug in 1, or let's say once we plug in negative 1, this is going to be 1 over negative 1 plus 1, which is going to be 1 over 0. This is going to be undefined, but we are trying to make the function to be defined. Okay, so in this case the domain is not going to be all real numbers. Now whenever you have been given a fraction, what you have to do, get the denominator, set it not equal to 0. So you say x plus 1 not equal to 0. Why are we saying not equal to 0? Because we can never have a 0 on the denominator. Once we have 0 on the denominator, the function is going to be undefined. That is very, very important. You have to know it. The moment I put 0, the moment I have 1 over 0, or maybe I have 2 over 0, this is undefined. And we are trying to make the function to be defined. That is the reason why we have to set the whole denominator not equal to 0. Okay, then solve for x. The value of x which we're going to find, that is going to be the domain. So in this case, it's going to be x not equal to 0 minus 1, x not equal to negative 1. So in this case, the domain is going to be x is such that x is not supposed to be equal to negative 1, but x can be any real number. So any real number, I can plug in any value of x, any value, as long as that value is not negative 1. This function is going to be defined. Okay, now you can represent domain either in set interval notation or in set builder notation. So this is the set builder notation which you have. If you want to represent it into set interval notation, you can say that the domain is going to be from negative infinity, I'm trying to write negative infinity here, okay, all the way to negative 1, but negative 1 is not included, union from negative 1 also not included, all the way to positive infinity. So this is going to be my domain, but negative 1 is not included. That's the reason why I'm using open. Okay, the moment I use close, meaning it is included, so it's not included. Now how do we find the range? The range, these are the values of y. Now to find the range, what you have to do is you need to find the inverse of this function. Once you find the inverse of this function, the same method which we are using on how to find the domain, that is going to be the same method which we are going to use to find the range. So range, these are the values of y. So when you're finding the inverse of the function, we put this, we'll present it with what, y, then make x as a subject of formula. So it's going to be, we cross multiply, it's going to be yx, or let's say xy. It's going to be xy plus y is equal to 1. My goal is to make x as a subject of formula. This is going to be xy. It's going to be equal to 1 minus y. I'll divide both sides by y, both sides by y. X will be equal to 1 minus y over y. Now, the values of, whenever we're talking about the range, those are the values of what? the values of y. So we know that the inverse is going to be the inverse of this function. Where there's x, we are going to put, is going to be 1 minus x. Where there's y, we present it with what? X. Then we have this. This is the inverse of the function. Now, the same method which we use to find the domain, that is the same method which we're going to use to find the range. So I'm going to get this, the denominator. I set it not equal to 0. So that will be my range. So range is going to be y is such that y should not be equal to 0. Y can be anything but should not be equal to 0. At the same time, y can be the member of all real numbers. So that is my range. So to find the range, just find the inverse. That will be the range. What next? Let's say we have another question, which is f of x is equal to, let's have x plus 4 over 2x plus, let me put minus 1. Let's find the range and the domain. You can pause the video and work on it. Okay, so to find the domain, we need just to get the denominator, set it not equal to 0, and find the value of x. 2x is going to be not equal to 0. Then you are going to have 0 plus 1. So we're going to have 2x, 1. So we divide both sides by 2, both sides by 2x, not equal to 1 over 2. That is our domain. So the domain will be equal to, x is such that x should not be equal to 1 over 2, but x should be the member of all real numbers. So this is the domain. You can put this in set interval notation, where you can say the domain will be from negative infinity to half, half not included, union, half not included, comma, positive infinity. So that is the domain. Okay, what else? Let's now see how we can find the range. We need to find the inverse of the function, the same method which we used on how to find the domain. That will be the same method which we're going to use to find the range. So y will be equal to x plus 4 to x minus 1. So we cross multiply, we are going to get 2xy minus y is going to be equal to x minus plus 4. Our goal is to find the x, to make x as a subject of formula. We can shift this x to the other side and the 1 to the other side. So we're going to have 2xy minus x is equal to 4 plus 1, which is going to be 5 that side. So you have 2xy minus x is equal to 5. We can make x as a subject of formula. This is going to give us 2y minus 1 is equal to 5. We divide both sides by 2y minus 1, both sides by 2y minus 1. X will be equal to 5 over 2y minus 1. So that is the inverse of the function. So this inverse here, if they ask you to find the inverse, you just say the inverse is going to be negative 1 f of x is going to be 5 divided by 2, where there's y you put x. So this is the inverse. Now you get this because we're trying to find the values of y. So you get this, set it not equal to 0. So it's going to be 2y minus 1 not equal to 0. Solve for y. Okay, I believe this is going to give us the same as the domain. So it's going to be 2y is going to be not equal to 1. So I divide it by 2. We're going to get this. We have 2y not equal to 1. We divide it by 2. We divide it by 2. Y not equal to half. So the range in this case is going to be y, range is represented by y because we're talking about the values of y. Y is such that y should not be equal to half, but y should be the member of all real numbers. You can also put this in set interval notation where you say it's going to be negative infinity all the way to half, then union half all the way to negative infinity, positive infinity. So that is the range. Okay, so let's have another example where we have something which is complicated just a bit. What are we going to have? Let's say we have f of x as 3x. Let's say 3x plus 2 over x squared minus 4. Get the denominator, set them not equal to 0. X squared minus 4 not equal to 0. X squared not equal to 4. So I get the square root both sides. I get the square root, meaning here I'm going to have plus or minus. So I have x not equal to plus or minus 2, meaning that my domain is going to be x is such that x should not be equal to plus or minus 2, but this x has to be the member of all real numbers. So I can also put this in set interval notation where I can say I need to have the values. The domain is going to be from negative infinity all the way to negative 2, not included union, then 2 all the way to infinity. But 2 and negative 2, they are not included. Okay, now how do we get to find the range? Find the inverse of the function. The same method which we use on how to find the range, that will be the same method which we're going to use. Now you can even test here. We are saying that x should not be equal to plus or minus 2. And for sure, if I plug in 2 here, it's going to give me 4, which is going to be 4 minus 4 is 0. On the denominator there, I'm going to have 0, which is going to be undefined. Probably we want our function to be defined. So what are we supposed to do? 2 is not supposed to be included. Negative 2 is not supposed to be included. Because once I plug in negative 2 there, I'm going to get a 4. 4 minus 4 is 0. So it's not supposed to be included. So that is making sense. Let's find the inverse now. So to find the inverse, we say y will be equal to 3x plus 2, 3x minus 4. This is going to give us 3x squared y minus 4 is equal to 3x plus 2. So what I'm going to do is I'm going to shift 3x to the left hand side and negative 4 to the right hand side. So I'm going to have minus 3x is going to be equal to 2 plus 4. So we're going to have 3x squared y. What else are we going to have? We're going to have we're going to have what? We're going to have 6 here. Okay. Oh, I have forgotten minus 3. Then you have 2. This is going to give us 6. So this is x. We are trying to make x as a subject of formula. What do? We factor out x. Okay. So if I factor out x squared, although this is not going to make sense, what I'm supposed to do here is, okay, so this is going to be we're going to have what? We're going to have 3y minus, so here I'm going to remain with again 3 over x. which is not making sense at the same time. Okay, so if it's not making sense, the meaning that this function has got no inverse. It has no inverse, so it has got no inverse. Okay, so you leave it there. Let's say we have another question, which is so if the function has got no inverse, it has got no range, because you can't find the range there. So it has got no it has got no the values of what? The values of y. So it is not restricted actually. So we have the next question, which is let's say we have now the radical one. F of x is equal to this. Okay, how do we find the domain? We know that we can never have a negative. Let's say we have a negative. We can never have a negative inside the square root. That is going to be undefined. Okay, meaning that what we have to do is we need just to get what is inside, set them greater than or equal to 0. We can have 0. We can have 0. We have the square root of 0, which is 0. 0 going up, or let me say 0 and above. That's making sense. The function is going to be defined. But we can never have a negative. So in this case, the domain is x is such that x has to be greater than or equal to 0. At the same time, x has to be the member of all real numbers. Using the set interval notation, you can say that the domain will be is starting from 0, but 0 is included, so I'm supposed to use the closed one. Starting from 0 all the way to positive infinity. But we don't know if positive infinity is included, so we'll put the open one. So this is the domain. Now to find the range, you need to find the inverse of this function. Finding the inverse, you know what to do. We are supposed to put y is equal to the root of x. What else? We square both sides to remove the square root because we're trying to make x as a substitute formula. We're going to have y squared is equal to x. Okay, so what are we going to have from here? We can see that it's the same as we have a function which is x. We have x is equal to y to the power 2. So we have nothing which is involved in this part here. I can plug in any number, the function is going to be defined. Okay, yeah, the function is going to be defined. So what values of y, if I plug in there, the function is going to be defined. Okay, so this is going to give me all real numbers. This is going to give me all real numbers. Now, we are going to talk about graphing of radical functions. So also talk about how to find the domain and the range of radical functions. Okay, so let's start. Let's say we have a function which is f of x is equal to the square root of x. Now, last time we mentioned to say whenever you are trying to come up with a domain, you have to set what is inside greater than or equal to 0. Okay, so I have to say x is greater than or equal to 0, meaning that that is my domain. But you can also find the domain and the range, especially the range. When it comes for the range for the radical function, it's very easy for you to know the range when you sketch the graph. Okay, so here we are saying that x has to be greater than or equal to 0, meaning that the values of x which we are supposed to use, they're supposed to be greater than or equal to 0. That's when this function can be defined. So we have x, y. So I'm going to say that well, I'm going to start from 0. 0 is included, so if I put 0 where there's x, the value of y is going to be 0. Next, if I put 1, the value of y is going to be 1 because the square root of 1 is 1. So what if I put 4? 4, the value of y is going to be 2 because the square root of 4 is 2. Next, I can say 9. 9, the square root of 9 is 3. I can end there. If you want, you can have 3 coordinates. That's just okay. So next what we're going to do is we're going to have our graph. Okay, here is going to be our graph. Y, this is our x. So we're going to have 1, 2, 3, 4, 5, 6, 7. Let me put another one here and another one. So meaning we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So we have in the y-axis we can have 1, 2, 3, 4. That is just okay. So next we can plot. We have 0, 0 is starting from this point. Then 1, 1 is this point. We have 4, 2. So this is 2. So 3, 4. 4 is this one. 2 is somewhere here. Okay, what next? We have 9, 3. 3 is here. 9 is somewhere here. So it's supposed to be somewhere here. So our graph will start from here. It goes there. Start from there. It goes there. So that is the graph of the square root of x. Now, from here you can find the domain. Domain, these are the values of x. So what values of x do we have? As we can see from the graph here, we have got 0. It's starting from 0 going to positive infinity, meaning that our domain is 0 is included all the way to positive infinity. That is the domain. Now the range, these are the values of y. 0 is included, so it's also starting from 0 all the way to positive infinity. That is our okay. So that is the parent graph which we have for the radical functions. Let's have a different thing now. Let's say we have f of x to be equal to the square root of 2 minus x. So what you have to do for you to know which, so let's talk about a piecewise function. So what is a piecewise function? So a piecewise function, this is a function which has got more than one equation. Perhaps you have seen an equation which is like this, or a function which is like this. Okay, so you're going to have maybe more than one function. Let's say we have got x plus 2, then the domain is x is less than or equal to negative 1. So each function has got its own domain. Okay, so we have 1, then you have got comma, negative 1 is less than x, x is less than 1. Then we also have x squared, then we have comma, x is greater than or equal to 1. Okay, now here they're going to ask you to sketch this and maybe find the value. Sometimes let's say they ask us to say find f of negative 1, also find f of 0, again find f of 3. So how do we find that? So before we go any further, let's first sketch the function. Okay, so sketching a piecewise function, it is very simple. What you have to understand is that you only follow the domain which have been given. So you only follow these are the domain. Okay, so the first part here, this is the domain for the first function, this is the domain for the second function, this is the domain for the third function. Okay, so now what is happening here is that what we're going to do, we're going to say this is our graph. So I'll put it here. This is going to be my graph. Okay, so here's my graph. Now this graph, what I'm going to do is I'll start with the coordinate which have been given. So as we can see from the domain which we have been given, we are going to be following the same conditions which have been given. So the first part, they're saying that x plus 2, the values of x are supposed to be less than or equal to 1. Okay, so I'm going to start there. I'm going to say this is going to be my x, this is going to be my y. So the first part is -1. So in this function, in this equation, if I replace -1 where there is x, what would be the value of y? Okay, because the condition here is saying that x is less than or equal to -1. So I need to start from -1. But at that point, since it is less than or equal to, the first point is going to be a closed one, meaning it is included. If it was x less than 1 or -1, I would have started with what? An open one, meaning it is not included. Okay, so here I'm going to start with that one. Then I'm going to say, if I put -1 in my first equation, I'm going to find that it's going to be -1 plus 2. So what is -1 plus 2? I'm going to get a 1. Okay, so I'm going to get a 1. Then if I put -2, it's going to be -2 plus 2 is going to give me a 0. So I'm going just to get three numbers or three values of x. Then let's also put -3. If I put -3, I'm going to find -1. Now, from here, what I'm going to do is I'll go to my graph. Okay, the x values which I have is I have -1, -2, -3. Allow me to put also -4. So I have these values here. Next, I'll go to my y. My y, I have got -1, -2. I'm going to put all the way up to -3. That's all. Okay. Then again, the first part here I'm going to put, okay, here I'm going to end on just 1 for the first equation. So I'm going to have -1, -2, -3. Then here I've got 1. So let's now plot the first which we have. So what is -1? -1 comma 1 is this point here. Okay, but at this point we are saying that it is included because it is x is less than or equal to -1. So -1 comma 1 is included, so I'm going to put a closed one. So 1 comma 1 is going to be at this point. I'm going to put a closed one, meaning it is included. Okay, I've put that one. Next, I'm going to go where there is -2 comma 0. So where is -2 comma 0? -2 comma 0 is this point here. Okay, then -3 comma 1, -3 is this one, 1 is here, so it's somewhere here, meaning that my point here is going to start from this point all the way going here. That is my point. So that is the first equation which we're going to have, meaning for the first part I'm done. For the first equation I'm done my sketching. I'll go to the second one. Okay, so what am I going to do in the second one? The second one, what I'm going to do is I'm going to have also x and y, but this one is saying the values of x are supposed to start from -1 all the way to 1, meaning that I've got -1 here, -1, 0 and the 1. That's all. That is the domain. So the domain for that one is just from -1, -1 not included, all the way from -1 not included to 1. So this is the domain which have been given. Okay, so that is what we're going to use. Those are the values of x. So in this one, if I put -1, I'm going to find that my value of y is going to be 1. I've been given already here. So any value which is within the range of -1 all the way to 1 is going to give me 1. So if I put -1, it's going to give me 1, but it's not going to be included at that point. 0 is going to give me 1, 1 is going to give me 1. So meaning that the first point is not going to be included. And which point is that? -1 comma 1. And -1 comma 1 is this point. So I'm going to put an open circle here to show that it is not included. Next, I'm going to say 0 comma 1. 0 comma 1 is this point. Okay, next is going to be 1 comma 1. So 1, I'm going to put 1 here. Okay, 1 comma 1 is going to be at this point. It's going to be at this point, meaning that at this last part it is not, or it is less than as well, so it's going to be an open one. It's not included as well, meaning that I need to put now the line joining these 2 points. I'm done that. So the second equation, that is my graph. That is my graph. Okay, now from there I'll go to the third one now. Okay, how do I go? How do I sketch that one? So I'm going to say that I'm going to have this x, y. So let's start now putting the numbers. So I have, they are saying that x is greater than or equal to 1. 1 is included. So I'm going to, if I put 1 squared, where there's x I put 1 squared is going to give me 1. Let's put 2 squared is going to give us what? 2 squared is going to give us a 4. Okay, let's put 3. Okay, 3 squared is going to give us what? It's going to give us a 9. So what we're going to do, since this is 1, let's put here 2. We put here 4, then here let's put 9 because we don't have space. So I'm going to say that this is going to be my 4, this is going to be my 9, meaning that from here now I can say 1 comma 1, but at this point 1 comma 1 is going to be included, so I'm going to put it inside there. Okay, so allow me to say this point here, let me just say, since it was open, I'm going to put an open one there. Okay, then now since this one is going to be closed, I'm going to put a closed one starting from there. That is where it's starting from. Now next point is 2 comma 4. So 2 comma 4, I'm going to put 2 here, and then I'm going to put 3 here. So 2 comma 4 is going to be this point. Okay, this point here is going to be 2 comma 4. Next is going to be 3 comma 9. 3 comma 9 is going to be somewhere here. Okay, this point. So I need just to join these lines. So I join these lines, that is going to be my third one. So now this graph which I have is the piecewise function which I have. This is the graph now. Okay, now from this graph we can see that we can even find the domain, the overall domain of this function. We can see that the x values, we don't know where it is ending, so it's going to be all real numbers starting from negative infinity all the way to positive infinity. That is going to be our domain because we don't know where it is ending. That's why I'm putting the arrow. These arrows simply means that we don't know where it is ending. Okay, so it can go all the way to positive infinity, that is x, all the way again to negative infinity. So it's going to be the domain is going to be all real numbers. What of the range? Even the y values, if we can check here, the y values are not restricted as well. So the y values, as we can see, is starting from negative infinity as well all the way to positive infinity. As simple as that. Okay, now the next question which we have to ask ourselves is what if we want to find f of negative 1? Okay, how are we going to find that? So f of negative 1, this is what we're going to have. Okay, so f of negative 1. So from these equations which we have here, we're going to choose the one which is telling us to say x is equal to what? Negative 1. So the first equation saying that x is less than or equal to negative 1, meaning that negative 1 is included. I'm going to get that equation. So I'm going to say that x plus 2. Okay, so f of negative 1 is going to be negative 1 plus 2. So what will be our f of negative 1? F of negative 1 is going to be negative 1 plus 2 is going to give me 1. So that is the answer for what? For part 1. Okay, cool. Now let's also find the second one. The second one is saying find f of 0. So we're going to choose the equation which is going to tell us to say x is what? 0. Okay, so which equation is that? So we have got f of 0. The first equation saying that x is less than or equal to negative 1, meaning that the numbers from negative 1 all the way to negative infinity, 0 is not included there. We can't get the equation 1. Let's go to equation 2. Okay, equation 2 is saying that negative 1 all the way to 1, but those two are not included, but in between there is 0, meaning that that is the function which we're going to get. Okay, meaning that f of 0 is going to give us what? 1, because we don't have anything apart from 1 here. So f of 0 is going to be give us 1. That's all. Now the third one is saying f of 3. How can we find f of 3? Okay, so f of 3, this is what we're going to have. F of 3 is going to be which equation are we going to get? We can't get the first equation because the first equation is saying that x plus 2, then x has to be less than or equal to negative 1, so we can't get that one. Second equation is saying negative 1 all the way to 1. 3 is not there. But the third equation is saying that x is greater than or equal to negative 1, meaning that the numbers from negative 1 all the way to positive infinity. So 3 is going to be in that one, meaning that we are going to say this is going to be x to a power 2. So f of the power f of 3 is going to be 3 squared. So f of 3 is going to be 3 squared is going to give us 9. So that is it for that one. Okay, so now let's say we have a different we have got a different function. Let's see how we can solve it. Okay, let's see how we can solve it. So let's say we have got a different one, and the same different one, let's say f of x is equal to, okay, so I'll draw this, let's say 0. That is then we start from -5 all the way to -5 less than or equal to x, then x has to be less than -2. Okay, now when I say -5 less than or equal to x, then less than -2, I can put this in set interval notation. So what it means there is that -5 is included, comma, -2 which is not included. So what it means is same as x is greater than or equal to -5. At the same time, x is less than -2, meaning that it's starting from -5. -5 is included all the way to what? This, but this is not included. That is what it means. So now what we're going to do here is the second one, let's say we have -x squared plus 4, comma, let's put -2 less than or equal to x, then let's say x is less than or equal to -1. So let's include both of them. So let's say also here we have -x, then we have plus 3, comma, let's say 2 is less than x, then x is less than or equal to 5. Now let's sketch this. We have to sketch, and then we need to find 1. We need to find f of -1. Again, we are going to use the same one, f of, we need to find f of 0. Then the third part, we have to find f of 3. So first, let's sketch the graph. Okay, so sketching this one is not going to be complicated, because we know that we are going to have this. Okay, that is what we're going to have. Let me have a nice one. So here is my graph. So what I'm going to do is I'll start with the first part. So the first part, we know that we are going to have x, y. So we have this. Now they are saying that the values are supposed to start from -5 all the way to -2. So I'll start with -5. If I put -5, the y value is going to be 0. Next is going to be -4. -4, the y value is going to be 0, because we don't have any x value here, meaning that that is the answer. If I put -5, the answer is going to be 0. I put -4, the answer is going to be 0. I put -3, the answer is going to be 0, all the way up to -2. If I put -2, the answer is going to be 0. Okay, so now from there, what I'm going to do is I'm going to start now putting this. I'm going to have my -1, -2, -3, -4, -5, -6. So I'm going to put here -1, -2, -3, -4, -5, -6. So they are saying that it is starting from -5, 0, but -5 is included, so I'm going to put a closed one. Okay, it is included because it is less than or equal to, so -5 is included. Next, -4, 0 is this point, -3, 0 is this point, -2, 0, it is also included. No, it is less than 2, so it's not included. I'm going to put an open one there. So my line is going to start from here all the way to this point. So that is going to be my first part. Okay, now next I'll go to the second part. So I'm going to have this as well, x, y. Now let's put the values. They're saying that from -1 all the way to 1. So I've got -1 or -2, sorry, -2 all the way to 1. So -2, we have got -1, 0 all the way to 1. So in this equation, it's x, -x squared plus 4. So if I put negative 2, now remember, when you have something like this, this is this. When you are plugging in the values, what it means is that it's going to be negative, then negative 2 squared plus 4. So this is going to give us, inside there is going to be 4, but 4 there is negative outside, is going to be negative 4. So negative 4 plus 0 is going to give us a 0. That is also very, very important. Don't make a mistake where you are going to say you plug in 2, then you think as if it's going to be positive. No, because negative is outside the x. Okay, so we're going to have another one, which is going to be it's going to be negative x squared plus 4. So if I put negative, then I have negative 1 I square is plus 4. It's going to be 1 squared is going to be negative 1 squared is going to be 1. So there's negative outside, so it's negative 1 plus 4, which is going to be what? It's going to give me 3. Okay, so I'm going to put my 3 here. What if I put 0? If I put 0, I'm expecting to have a 4, because it's going to be 0 squared is 0. 0 plus 4, we have 4. Next, we have 1. Okay, so the first point is going to be included. It is included. Even the last point is going to be included. So the last point is going to be 1. If I put 1 there, it's going to be 1 square. So it's going to be negative 1, comma. I'm going to have what? If I have 1 squared, it's going to give me a 3. Okay, it's going to give me a 3. So I'm going to start now from there to say the first point is included. So I'll come there and say my first point, I'm going to have this is included, which is negative 2 comma 0 is this point. So I'm going to put it inside. It is included, yes. Okay, it is included. Next, negative 1 comma 3. Allow me to put 1 here. Let me put 2. I put 3 here. Let me put 4. I put 5. So I have 1, 2, 3, 4, 5. So next point is the first point was negative 2 comma 1. That is the first, or negative 2 comma 0. That is the first point which I've shaded it. The next is negative 1 comma 3. Is this point here. Then we have 0 comma 4. Okay, which is this point. Next we have 1 comma 3. So I'll put 1 here, 3 is here. So it is starting from here. Okay, let me use different color. It is starting from this point all the way there, then here. But the last point is also included, so I need to put I need to shade it. So that is the second part. Now the third part, what I'm going to do is I'm going to say I have x again, I have y, so I have this. So I'm going to have, starting from 2. 2 is not included, so the first point is going to be open. Okay, so 2 is not included. If I put 2 there, what's going to be my answer? Negative 2 plus 3, I'm going to have a 1. Okay, I'm going to have a 1. Next, I'm going to put a 3. It's supposed to end on 5, 3. So if I put 3 there, negative 3 plus 3 is going to give me a 0. Next, I'm talking about this equation here. That's where I'm plugging in the values. So now, next I'm going to have what? I'm going to have a 4. If I plug in 4 here, negative 4 plus this one, I'm going to have a negative 1. Okay, next I'm going to have a 5. But at this point where there's 5 is going to be included because it is less than or equal to. So if I put 5, it's going to be negative 5 plus 3. So what is negative 5 plus 3? Negative 5 plus 3 is going to give me a negative 2. So I'm done. Now from there, the x values are supposed to go all the way up to 5. So I've got 1, 2, 3, 4, 5. Let me even put 6. So I have got 1, 2, 3, 4, 5, 6. As simple as that. Next, what I'm going to do is I'm going now to plot this. So allow me to put negative 1 here. Then I put negative 2. Negative 1, negative 2. So I'm going to have 2, comma 1. Okay. So 2, comma 1 is this point. But at this point, it is open. It is not it's going to be open. Next is 3, comma 0 is this point. 3 comma 0 is this point. Next, 4 comma negative 1. 4 is this point, negative 1 is somewhere here. Okay, another one is 5 comma negative 2. 5 is here, negative 2 is somewhere here. So our point will be here. This is going to be our point. Okay, so don't forget to put the arrows because we don't know where it is ending. So this is the sketching. It will be our f of, we start with f of negative 1. Okay, so f of negative 1, which function are we going to get? Let's start with the first function. So the first function saying negative 5, negative 5 is less than or equal to x, then x is less than negative 2. Negative 1 is not in that range. So the first equation has failed. Let's go to the second one. Negative 2 less than or equal to x, then x is less than or equal to what? To 1. Meaning that that one is going to work because it is from negative 2 all the way to 1. So negative 1 is in between. So we're going to get that function. It's going to be negative x squared plus 4. Now we plug in the values. Negative 1, so we're going to have negative 1 squared plus 4. So what will be our f of negative 1? So f of negative 1 is going to be negative 1 squared is going to give us a 1. So we're going to have negative 1 now plus 4 because of the negative which is outside. So f of negative 1, we're going to have a 3. So this is going to be the answer for f of negative 1. Okay. Now what of f of 0? Which one are we going to get? Let's see. So f of 0, let's check the first one. So the first one is saying from negative 5 all the way to negative 2. 0 is not in that range. The second one is saying from negative 2 all the way to positive 1, meaning that 0 is in that range. So we're going to get that one again. So it's going to be negative x squared plus 4. So f of 0 is going to be, then we have 0 squared plus 4. So our answer is going to be f of 0 is going to be 0 plus 4 is going to give us a 4. So that will be the answer for f of 0. Okay, so that is also very, very important, you knowing to say which equation am I going to use if I've been given f of 2, f of what. Yeah, so f of 3 now, which one do we expect? We expect the third one. The third one, that's why I'm saying 2 all the way to 5, meaning that 3 is in that range. So it's going to be, I'm going to get this equation. Okay, so f of 3 is going to be negative, I'm going to replace where there's x, we replace it with what? 3. This plus 3. So f of 3 is going to be equal to 0. As simple as that. So this is what you need to know under piecewise function. So let's talk about even and odd functions. So how do you know that a function is even or odd? So a function is said to be even if f of negative x is equal to f of x, meaning a function is what? Even. And the function is said to be odd function if f of x, if f of negative x is equal to negative f of x. Okay, then we're going to say that this is an odd function. So if you discover to say the function is not giving us this and at the same time it's not giving us this, meaning that function is neither of the two, is neither even nor odd, so we just say the function is neither. Okay, so there we go. Let's have some examples. Okay, so let's say we have got a function which is f of x is equal to 3x squared minus 4x to the power 4. Let's see if this function is odd, even, or neither. Okay, so there we go. So a function, like we said, a function is said to be even if f of negative x is equal to f of x. So if we plug in negative where there's x and we get the original function, then that function is even. But if we plug in the value of x with negative x and we get negative f of x, then the function is odd. Okay, so for example, we have got an example here. So this is going to be f of negative x is going to be equal to, so it's going to be 3 negative x squared minus 4 negative x to the power 4. Okay, so we are saying that this is going to be f of negative x is going to be equal to negative x squared is going to give us x squared, so it's going to be 3x squared minus x to the power 4 is going to be x to the power 4. So we are going to have this. So as you can see, we are getting f of negative x, then we are getting the original function, which is going to be equal to f of x. So since f of negative x is equal to f of x, then this is an even function. Okay, so this is how you prove to say it is an odd or even. Now let's have another example. Let's say we have f of x is equal to 3x squared minus 4. Okay, this is what we're from having. Let's have this. F of x is equal to x to the power 3 plus 1. Okay, so we know that for a function to be an even, f of negative x has to be equal to f of x, and for a function to be an odd, f of negative x has to be equal to negative f of x. So let's see if this function is even or odd function. Okay, so we're going to say f of negative x is equal to, we're going to have negative x to the power 3 plus 1. So f of negative x is going to be equal to negative x plus 1. So let's try to factor out a negative. Okay, so f of negative x is going to be equal to negative x, then again we're going to have negative here, negative 1. So as we can see, f of x, negative x, is not equal to this f of x. So this function is not even. What of odd? Okay, odd, unless if we have got a negative outside, then inside here it's supposed to give us the original function. But at the same time, this function f of negative x is not equal to negative f of x. So this function is not an even. At the same time, it's not an odd. So this function is neither. As simple as that. Okay, so let's have another example. Let's say we have a function which is f of x is equal to 6x to the power 3 minus 5x. So let's say we are saying that for a function to be an even, f of negative x has to be equal to f of x, and for a function to be an odd, f of x has to be equal to negative f of x. Okay, so let's now see what's going to be our f of negative x. So f of negative x, we're going to have 6x to the power 3 minus 5 negative x here. Okay, so what are we going to have? F of negative x, we're going to have negative x to the power 3 is going to give us negative x, so it's going to be negative 6x to the power 3. The minus, we've got negative is going to give us a positive 5x. So let's factor out the negative. F of negative x is going to be equal to negative, then we're going to have x to the power 3 minus 5x. So as we can see, we have got a negative here. So we have got f of negative x is equal to negative f of x. Now inside here we need to get the function which is exactly the same as the original function. If we factor out negative, then we are going to conclude that since this is negative f of negative x is equal to negative f of x, then this is an odd function. Okay, let's have another example. So let's say we have f of x is equal to 1 minus x squared. Let's see if this function is even or odd. So let's not forget, for a function to be an even, f of negative x has to be equal to f of x. For a function to be an odd, f of negative x has to be equal to negative f of x. As simple as that. So let's see. So we have got f of negative x is going to be 1 minus negative x squared. So we're going to have f of negative x is going to be equal to 1 minus negative x squared is going to give us x squared. So this is giving us exactly the original function. So since f of negative x is equal to f of x, then we can conclude to say this is an even function. As simple as that. Okay, so let's have another example. Let's have another question. F of x is equal to x squared minus x. Let's see. So f of negative x is going to be equal to um, negative x squared minus negative x. So this is going to give us f of x is equal to um, x squared. We're going to have x times negative x times negative x. We're going to have this. Okay, so f of negative x is not equal to f of x, so this is not an even. At the same time, f of negative x is not equal to negative f of is not equal to negative f of x, so it's not an odd. Therefore this function is neither. So this function is neither odd, no, even. Okay, let's have another example. So let's say we have f of x is equal to 3x squared. Let me put x squared then plus 2x minus 1. So let's see, for a function to be an odd, f of negative x has to be equal to f of x. Let's not forget that point, very important. At the same time, for a function to be an odd function, f of negative x has to be equal to negative f of x. So let's see, so f of negative x is going to be 3 negative x squared plus 2 negative x minus 1. Okay, so f of negative x is going to be equal to 3x squared, because negative x squared is going to be x squared, minus this is 2 times negative x is going to be 2x minus 1. Okay, now this is not giving us exactly the same as the original function. Okay, so the original function is this, there is a plus here and here there is a minus, so it's not the same. Now let's try, so since it's not the same, it's not an even. Let's see if it's an odd. Let's factor out the negative. So if I factor out the negative, I'm going to have negative 3x squared plus 2x minus 1, or plus 1. But again, I'm having some changes here, negative and then here, which is not the same. So this again is not the same as the original one. So this function is not an odd function, therefore it's neither. So if you discover to say it's not an odd and it's not an even, then the function is neither. Okay, so now let's have another one. Let's say we have f of x is equal to x plus 1 over x. Is this function even or odd? Okay, so f of negative x is going to be negative x plus 1 over negative x again. So this is going to be negative x is going to be equal to, we're going to have negative x, this negative there, we're going to have negative 1 over x. Now this is not the exact as what we have there, therefore it's not an even function. Let's try to factor out the negative. Okay, so if I try to factor out the negative, I'm going to find that I'm going to have negative x here plus 1 over x. Now we can see that what we have inside here, it's the same as the original function. Therefore, since f of negative x is equal to negative f of x, then this function is odd. As simple as that. So this is how you know to say this function is odd or even. Okay, now let's have the last example. Let's say we have f of x is equal to the modulus of x. Okay, now since we know that any value which is going to come out from here is going to be positive, now we are saying that if this is giving us this, then this is an even. If this is giving us negative f of x, then this is an odd function. So now let's see if this is going to be even, odd, or neither. So we have got f of negative x is going to be equal to negative x. Now we know that in modulus we're going to come up with only positive values, so this is going to give us a positive x. Okay, now if this is positive x, we can see that this has given us the original function. Okay, therefore this is an even function. As simple as that. So this is how you know, or this is how you determine to say the function is an odd, even, or neither. Okay, we are going to talk about completing square method. Okay, so completing square method, we are going to have a function which is in form of f of x is equal to ax squared plus bx plus c. Now the first step here is we have to factor out a. Okay, so if I factor out a, I'm going to remain with a x squared plus b over a x plus c over a. Okay, so the first point here is you always factor out a. The reason why we are factoring out a, we want our turning point to be in a form of a, open brackets, x plus p. Okay, then we have squared plus q. Now that's the reason why we are factoring out what? The a. Okay, so we will keep on bringing the a there. So now the next step here is you get the coefficient of this x which is here. Now you do times half. Okay, what is the half of b over a? So you say b over a times half, which is going to be b over 2a. Okay, so this is going to be a x squared plus b over a x plus, now this is going to be b over 2a. Now this has to be squared. The same thing which I've done here, I'm going to say minus the same thing now, b over 2a, I also have to be squared. The reason why I'm doing this is if I do this minus this, I'll go back to my original equation. Okay, then I'm going to put now this, so this is going to be plus. Now I have c over m, then I do this. So what I'm going to do here is I'm going to ignore this. So now if the moment I ignore this, I know that this is squared, this is also squared, then it can be written in this form. It can be written in a, I have x plus b over 2a, then I do this, I put a squared. I have not changed anything. So I'm going to say minus this one. I can say b times b is going to give us a b squared. Then this is going to give us 4a squared. This is going to be plus c over a. So I have this. Now from here, what I'm going to do now is I need to make this as one thing. What I mean there is I can get rid of this on top here. I can say that I have negative b squared over 4a squared plus c over a. The lowest common denominator is going to be 4a squared. So this there is going to be 1 times that one, we're going to get a negative b squared plus a here we're going to get a 4a times that one, we're going to get a 4ac, meaning that I'm supposed to replace this with what I have there. So I'm going to have a, open brackets, I have this. Okay, I square it, then I have minus b squared plus I have 4ac, everything divided by what? 4a squared, and I have this. So what I'm going to do, I'm going to distribute now a. So if I distribute a, you're going to see that this is what we're going to have. Let me first get rid of this. So what we're going to have here is we're going to have a x plus b over 2a, then it is squared. So minus, if I put this is going to be cancelled with 1a down there. So we are going to remain with negative b squared plus 4ac over 4a. So what it means there is that whenever I'm trying to find this part, we are trying to come up with this a x plus p squared plus q. So whenever I'm trying to come up with p, meaning that this p is the same as b over 2a, okay, then in my q is the same as I get this, okay, I get this. So now it is the same thing. Now whenever so this is going to be our turning point. Our turning point now is going to be this. So our turning point here is going to be, our turning point is going to be b over 2a comma negative b squared, okay, then we are going to have plus 4ac over 4c. So this is going to be our turning point. Then now whenever we're trying to find the line of symmetry, we just equate this part which is inside equal to 0 and find the value of x. That is the line of symmetry. So let's say we have a question. We have this, they are saying using completing square method to find the turning point x and y-intercept and sketch the graph and also find the line of symmetry. So we have the first question here which is saying so we have this one. So the first point we said is to factor out the a, okay. So if I factor out a here, which is going to be 3, I'm going to have x squared plus, here I'm going to have 2x minus, here I'm going to have 4 over 3. Now from here, what else do we have? We said we need first now to find the half of this part here. So I'm going to find the half of that one, so we're going to remain with this. We're going to have 2x. Half of this is 1, so we say plus is going to be 1, now we square it. The same thing is going to be minus 1, now we square it again. Minus 4 over 3. And then I do this. Now from here, I know that I'm supposed to ignore this. I'm going to get this part and this part only. So I'm going to have 3x plus 1. I square it minus 1 squared is going to be 1 minus 4 over 3. This is what we have. Now if we have negative 1 minus 4 over 3, it's the same as we have negative 3 over 3 minus 4 over 3, because negative 3 over 3 is negative 1. So this is going to give us negative 7 over 3. So this part is going to be 3, then x plus 1 squared minus 7 over 3. Okay, so I have this. Now I can distribute now 3. Okay, I'll get rid of this. I can now distribute 3. So if I distribute 3, I'm going to have 3 x plus 1 squared minus it's going to be 3 7 over 3. Now 3 and 3 can go. Okay, 3 and 3 can go. We are going to have this minus 7. 3 and 3 will go. We are going to have this. So meaning that what we have here is in the form of a x plus p plus q. So we can see that our turning point here is going to be what we get here is we get the opposite of this. Okay, so in short, what I'm trying to say is we equate this equal to 0. So for x is going to be negative 1, so that is the value of x. So we have negative 1 comma negative 7. These are the turning points. Okay, now from there, what else do we know? We can see that negative 1 comma negative 7, that is our turning point. That's where the graph is going to turn. Now from here we can also find the x and y intercept. Now to find the line of symmetry, this is the line of symmetry. You just equate what is inside equal to 0 and find the value of x. That is the line of symmetry. Okay, now to find the x intercept, or let's start with the y intercept. To find the y intercept, if you want to find the y intercept, set x equal to 0, meaning that in this equation where there's x, let's put 0. So our y is going to be negative 4. Okay, so we're going to have 0 comma negative 4. That will be our y intercept. To find the x intercept, same, we equate y to be equal to 0. So let's just put this here. We are saying that our turning point is negative 1 comma negative 7. What else do we know? We also know the y-intercept. Okay, the y-intercept. The y-intercept we found that is 0 comma in x0, then negative 4. To find the x-intercept, what we have to do is set y equal to 0. Then we are going to find the x-intercept, meaning that what we have there is we have 3x squared plus 6x minus 4 is going to be equal to 0. So for x, this is not factorizable. What are we going to do? We are going to use the bus method. So we're going to use x is equal to negative b, this b squared minus 4a, c, everything divided by 2a. So we have x is equal to, our b is 6, so we're going to have negative 6 plus or minus. We're going to have b squared is going to be 6 squared minus 4, a is 3, c is negative 4. So we have this 2 times 3. So x is going to be equal to negative 6 plus or minus. Inside here we are going to have 36. Then this is going to be plus. So we have 12. And then we have 12 times 4. So 12 times 4, which is 48. So we have plus 48 here. Then you have everything divided by what? 6. Okay, so we can get rid of this, the top part here. Okay, then now what else? We can see that 48 plus 36, we are getting 84. So we're going to have x is going to be equal to this. We're going to have 84 over 6. Now we don't have the square root of 24. We don't have the square root of 24, but if you use a calculator you can find the square root of 24. But now the issue is if you're not allowed to use calculators, you can leave your answer inside. So here I'm going to use a calculator. Okay, so we're going to say that what is the square root of 84? Square root of 84 is 9.17. Okay, so we're going to have x, but if you're not allowed to use a calculator, you can leave your answer inside. So it's going to be, we're going to have 9.17, everything divided by 6. So we're going to have two values of x. X is going to be equal to negative 6 plus 9.17 over 6, or x will be equal to negative 6 minus 9.17 over 6. So what will be the values of x now when y is equal to 0? So we're going to have x will be equal to, we have negative 6 plus 9.17. Okay, so I divide this by 6. I'm getting 0. I'm getting a 0.53. 0.53. I've just rounded off. Then another one is x is equal to negative 6 minus 9.17. I divide it by 6. I'm getting a negative 2.53. So now we have the x-intercept. When the y is 0, we have 0.53 comma 0, and also negative 2.53 comma 0. So these are the x-intercept, and those are what? The y-intercept. Now how do we sketch now the graph? So it is very, very, very simple now. Since we have everything, it's just a matter of us plugging in the values here. So we have this and this. Now the value of a, remember that when the value of a is less than 0, our graph is going to be at its maximum. Okay, it's going to curve like this. If the value of a is greater than 0, like in this case our value of a is greater than 0, the graph is going to have its minimum point. We're going to have this. That is very, very important. So before you even you even sketch the graph, you'll be able to know that the graph is going to be at its maximum or minimum. So if the a is less than 0, just know that the graph is going to be like this. Okay, When the a is greater than 0, the graph will have its minimum point. That is also very, very important. Now we have the values. We can see that we have, let's say we have a 1 here, a 1, a 2, and a 3. So we have 1, 2, 3. So here let's also have a negative 1, negative 1, negative 2, negative 3. Okay, so we have negative 1, negative 2, negative 3. So we have a 1, 2, 3, 1, 2, 3. Here we're going to have negative 1, negative 2, negative 3, negative 4. Because the turning point is at negative 7, I need to go all the way to negative 7, negative 5, negative 6, negative 7 here. Now what we have to know is that is our turning point. Negative 1 comma negative 7 is this point here. Okay, then we have the y-intercept where the graph is going to cut is negative 4. So this is our negative 4 here. Okay, when the graph rests there, it's going to turn at negative 4 in the y-axis. Now in the x-axis we have 0 comma negative 0 comma 5.3, which is somewhere here. Okay, then we have also negative 2.53, which is somewhere here. Okay, comma 0. So meaning that the graph is supposed to come from here, it goes all the way to this point, then it rests here, then it goes where there's 4, then it goes there. So that is our graph of f of x is equal to 3x squared plus 6x minus 4. Now the line of symmetry, we said it is at 1, negative x is equal to negative 1. So this is our line of symmetry. You just put this, so that is our line of symmetry. At x is equal to negative what? Negative 1. That is also very, very important. So this is how you can find the x-intercept, the y-intercept, the turning point, and also the line of symmetry, and also how to sketch the graph using the completing square method. Yeah, that is very, very important. So we also have a question 2 here, which we can just solve. You can pause the video and work it out and see the answer which you're going to come up with. Okay, so we have the second question, which is saying f of x is equal to x squared minus 4x. Remember we said is to factor out to factor out the value of a. So in this case a is 1. So if you want, you can just put 1, then you have x squared minus 4 x. We don't have anything here, it's 0. Okay, so we need to find the half of this. That is also very, very important. So we have 1, so we have x squared minus 4x. Now it's going to be plus the half of this. What is the half of negative 4? It is negative 2. So I'm going to put a negative what? I'm going to put a negative 2 there. Okay, so I'm going to put a negative 2 here. I'm going to put a negative I square minus, I need to get the same thing, I also square it, then I have this. Okay, so what we're going to have here now, we're going to have 1, we're going to have, we ignore this, that's what we said, we ignore this, so we just get this and this. Okay, so we're going to have x minus 2 squared minus negative 2 squared is 4, so we're going to have this, meaning that we have now 1 x minus 2, then 4. Now to find the turning point, we say that the turning point, I can get rid of this, I no longer need that. The turning point, this value is supposed to be the opposite. Okay, so x minus 2 is equal to 0. Find the value of x. That will be our first turning point, the turning point in x axis. So it's going to be 2 comma what? Negative 4. This one you just get the way it is. If it is negative, just get negative. If it is positive, just get positive. But this part here, if this is negative, get a positive. If it is positive, get a negative. In short, just get what is inside, set them equal to 0, then solve for x. At the same time, that is the line of symmetry. Okay, then now what we need to find is we need to find the x and y intercept. How do we find the x and y intercept? Okay, if it is factorizable, if I want to find the y intercept, what I need to do is to find the y intercept, set x equal to 0. Okay, that is y-intercept. X has to be equal to 0, meaning that f of 0 is going to be 0 squared minus 4 then 0. So this is going to give us 0 comma 0. Okay, so that is our y-intercept. Our y-intercept is 0 comma 0. Now to find the x-intercept, set y equal to 0. Okay, that will be our y has to be equal to 0. This is our y, our x-intercept. So it's going to be x squared minus 4x is equal to 0. I can factor out x minus 4 is equal to 0. So x will be equal to 0. At the same time, x minus 4 will be equal to 0. X is going to be equal to 4. There is going to be 4. So we have two x-intercept. So we have x-intercept, which is going to be 0 comma 0. We are going to have also 4 comma 0. After finding this, the line of symmetry, we know already that is going to be 2 because we have to set that one equal to 0. So the line of symmetry is going to be at x is equal to 2. So to sketch the graph now, we are going to see that this is going to be like this. Okay, let's put it this side. Okay, at the same time, we know that our a was greater than 0. It was 1 actually. So the graph is supposed to be having its own minimum. That's why it is negative, this part here. Okay, so before you even sketch the graph, you know that the graph is supposed to be like this or supposed to be like this. That is also very, very important. So now what we're going to have to do here is we're going to have our values here. We're going to have 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Then I'm going to have my values here 1, 2, 3, 4, 5. Okay, so -1, -2, -3, -4, -5. So here I'm going to have 1, 2, 3, 4. This is the y-axis, this is the x-axis. Okay, so I'm going to have 1, 2, 3, 4. I'm going to have -1, -2, -3, -4. That is just okay. -1, -2, -3, -4. Now from here I need to find the y-intercept is 0, 0. 0, 0 is this point. Then x-intercept foot again we have 0, 0. So it's going to be at the same point. Okay. Then the turning point is 2 all the way to 4. So it's this point here. That's the turning point. That's the turning point. That's where the graph is going to turn. Now we have also the line of symmetry is at the same point. Then we have 4, 0 is this point. So the graph is supposed to come here. When it comes here, it rests, then it goes there. So this is my graph of f of x is equal to x squared minus 4x. The line of symmetry is at this point, is at 2, -4. So this is at 2, -4. So you can say that this point is at negative, or is at 2, 4. 2, -4. So this is how you go up with the completing of square method. We are going to talk about completing square method, which involves modulus. So how do we sketch? Now we have got a question which is saying complete the square of each of the following quadratic functions, hence sketch its graph indicating the turning point and the intercept, and write down the equation of each line of symmetry. So as you can see, part 1 has got modulus, but there's no negative. Part 2 there's modulus, but there's negative. I think if you manage to check the previous video where we introduced the completing square method, we talked about how to find the line of symmetry, how to find the x and y intercept, and also how to find the turning point. Now here I want just to talk about what if you have been given the modulus, how do you sketch? So let's talk about how to use remainder theorem to find the remainder. So I have two questions with me. The first question is saying 2x to the power 3 minus 3x squared plus 4x plus 5. Then they're saying if it is divisible by this.